Hello everyone, I am Santosh MV, working as Assistant Professor in Department of Chemistry from VTU PG Center, Mysore. So I am here today to discuss about the solar energy, how it can be used for the production of electricity by using photovoltaic cell. And we need to discuss about the construction, working, applications and limitations of photovoltaic cell today. So before moving directly towards the photovoltaic cell, first we need to discuss about solar energy. It's a non-renewable source of energy which can be extracted to abundantly and which is available in abundant and which can be used for the production of heat or electricity by converting the solar energy into electrical energy by using a specific device which we call it as photovoltaic cell. So how this photovoltaic cell has been constructed? Before going for photovoltaic cell, first we need to discuss about the material which we use for the construction of these photovoltaic cells. If you know about this introduction, then only it will be very easy to understand the mechanism behind the working of this photovoltaic cell. See, photovoltaic cell, it is a device which converts solar energy into electrical energy. So how it converts the solar energy into electrical energy? And the conversion of solar energy, which will be having electromagnetic energy in the radiations that has been released by sun, when it falls on a particular device, that device should have the ability to release electrons and hole pair when this electromagnetic radiation hits the surface of these PV cells. When they hit the surface of the PV cells, how these electrons has been generated? That is one of the biggest question which you people should know here. So then only it will be easy to understand the principle behind these PV cells. See, the manufacturing of these PV cells is done by using a very specific material, what we call it as semiconductors. So these semiconductors which have the property of both an insulator as well as a conductor, and it has been synthesized or manufactured by using silicon as a raw material. We know that silicon is one of the abundant material which is present on the earth crust, which can be easily extracted. And when this silicon is doped with certain impurities like phosphorus and boron, it leads to semiconductor. So we are familiar about this doping process. So doping is nothing but addition of impurities to the pure metals to enhance their properties. It might be its conducting property or it might be its insulating property. But here for PV cells, since we are using these semiconductors as a raw materials for the manufacturing of these photovoltaic cells in terms of modules or arrays or panels, so the material which we use here is purely made up of silicon. See, when silicon, it is a tetravalent, okay, and it has the ability to form 4 bonds with the other chemical substance, because silicon has 4 electrons in its outermost shell. It has 4 electrons in its outermost shell. Silicon in its purest form, you should know this, it doesn't exhibit a good conductivity. So silicon, when it is doped with certain impurities, then only it exhibit conducting property, and hence that conducting property will not match with a good conductor and it will be present in between. Hence we are calling it as a semiconductor. So when this silicon, when it is doped with boron, boron is a trivalent atom. It is a trivalent atom which has 3 electrons in its outermost shell, and this boron has the ability to give all these 3 electrons to combine with silicon, and silicon is a tetravalent. What happens? This boron, okay, when it is combined with silicon, it leads to formation of 3 covalent bonds with the sharing of electrons, whereas the another one electron which is present in excess in tetravalent silicon, so there creates a hole. A hole is nothing but a empty place where the boron doesn't have the ability to fill that particular place because it has only 3 electrons in its outermost shell and it is behaving as a trivalent atom. So when trivalent is combined with silicon or tetravalent, a hole has been created here, and hence when boron is doped with silicon, we call this particular material as p-type silicon, p-type semiconductor, p-type semiconductor. Okay, p-type semiconductor. Next, when the same silicon, it's a, as I told, tetravalent, which has the ability to form 4 bonds with other atoms. When it is doped with phosphorus, phosphorus is a pentavalent atom, means it has 5 electrons in it. Okay, it has 5 electrons in its outermost shell, and when this pentavalent, that is phosphorus, when it is mixed with silicon, this phosphorus, it has the ability to form 4 bonds with tetravalent silicon, and since phosphorus is having 1 extra electron, so this extra electron will be present in N-type semiconductors. N-type semiconductors. N-type semiconductors. Semiconductors. So, in this case, if you observe, the p-type semiconductor, which is obtained by doping boron atom along with silicon atom, it's creating a hole, and at the same time when silicon is doped with pentavalent, that is phosphorus, we are getting n-type semiconductor where electron is present in excess. Electron is present in excess. So when both the case, that is p-type and n-type, have been combined together, when p-type semiconductor come in contact with n-type semiconductor, we call that particular junction as p-n junction, and at this particular junction, there the electrons, emission of electrons takes place when electromagnetic radiations falls directly on this p-n junction. And why there is electrons and holes pair has been created at p-n junction when an electromagnetic radiation, that is solar radiation, falls on that particular material, is due to the presence of this hole and extra electron which has been produced when p-type and n-type come in contact with each other. Okay, so if this is clear, we can go for the next topic, that is construction and working of PV cells. So this is about the introduction towards the doping of silicon, which is the major material which is used for the production of or the synthesis of PV cells. Okay, so now we shall go for the discussions of photovoltaic cell. Photovoltaic cell. We know what do you mean by cell. Cell is nothing but a device which converts chemical energy into electrical energy. But here we are using the word called as photovoltaic cell. Here it is a device which converts the solar radiation into electricity. Solar radiation into electricity. Hence we are telling it's a photovoltaic cell. Okay, the electrons or the photons which has been present in the electromagnetic radiation, when it falls on p-n junction, there leads to electrons, emission of electrons, and the released electrons, they will be converted from ground state to excited state when it absorbs the solar radiations, and when it is there in the excited state, the amount of energy which has been trapped by that particular electrons will be used for the synthesis of electricity. Hence, in this photovoltaic cell, we are using or we are converting the solar radiation into electricity. So the device which converts solar radiation into electricity is called as photovoltaic cell. So now we shall discuss about the construction of this photovoltaic cell, how it will be constructed. See, photovoltaic cell, it mainly consists of p-type and n-type semiconductors. It mainly consists of p-type and n-type semiconductors. As I told, p-type, okay, it is mainly present at the top, and n-type semiconductors will be present next to p-type. Okay, so here there's the presence of p-n junction. There's the presence of p-n junction. So p-n junction is nothing but a place where both n-type and p-type come in contact with each other. N-type and p-type will be in contact with each other. We call it as p-n junction. Okay, we call this as p-n junction. Okay, so this is n-type semiconductor. N-type semiconductor means the silicon which is doped with phosphorus, and this is p-type semiconductor. P-type semiconductor means a silicon which is doped with boron. Okay, so at the top there will be anti-reflecting coating which will be present. It will be like this. Why it will be coated with anti-reflecting coatings means once the solar radiations falls on the surface of this panel, that is PV cells, so maximum amount of radiations should get absorbed completely. So that's why it will be coated with anti-reflecting coatings. Okay, so this anti-reflecting coatings, it is purely made up of titanium dioxide, which doesn't allow the radiations to escape so easily or reflect back, and hence it allows whatever the radiations that has been falling on the surface area of the PV cell. So just assume this as sun, which is releasing solar radiations, and solar radiations will be falling on the surface area of PV cells, and it directly hits the PN junctions. Okay, and this will be connected with an outer source where there's the presence of current collectors at the end of the or the bottom of the PV cells, and both side has been connected through an outer source, and this is the bulb which has been fitted, which lights up or which produces light when electrons are flowing through the outer circuit. When electrons are flowing through the outer circuit. Okay, so here electrons and hole pairs will be created, and holes will migrate towards n-type and electrons will migrate towards the p-type semiconductors. Okay, so this represents a simple construction of PV cells. Okay, so there is a presence of silver in the backside of these PV cells, which brings the contact between the upper layer and the lower layer here. Okay, and it has been connected through an outer circuit where the electrons flow through the outer circuit, whereas the holes and electrons which has been produced at the PN junction will move towards n-type and p-type semiconductors respectively. Okay, So after knowing about the simple construction of these PV cells, next we need to know about the working of these PV cells, how these PV cells will be worked. See, working can be explained by considering this simple diagram itself. So when solar radiation, when it falls on this PN junction means where P-type and N-type semiconductors combined together. Okay, when a solar radiation, when it falls on this particular PV cells, due to the presence of anti-reflecting coatings, which is purely made up of titanium dioxide, which doesn't allow the radiations, whatever that falls on the surface area will be completely trapped. So we know that this solar radiation, it contains its own energy. It's an electromagnetic radiation which contains its own energy. Okay, and when it falls on the surface area of the PN junction, what happens? The electrons which are present here, okay, in the PN junction, these electrons will accept the energy from this electromagnetic radiation and they get converted from ground state to excited state. They gets converted from ground state to excited state. Why it gets converted from ground state to excited state means we know that each electron will be having its own energy because it will be rotating in its own axis in any particular atom. So when extra energy has been absorbed by those electrons means then its oscillation gradually increases. So due to its oscillation, increased energy level, it gets converted from ground state to excited state, and at the same time the holes has been generated here due to the presence of p-type semiconductor. So when electrons and holes pairs has been generated in PN junction, what happens? Since electrons is having a very high energy, it starts moving towards the p-type semiconductor and it gets collected at anodic site. And holes, it gradually moves and it will be collected in the current collectors at the bottom of N-type semiconductor. So you can see the movement of holes towards the N-type semiconductor, and at the same time the electron starts moving towards p-type semiconductors. So when electrons reaches the p-type semiconductor, here you can see the presence of outer circuit which has been connected through the other end of the photovoltaic cell, and these electrons will move towards this outer circuit, and as they move, what happens? Their energy level gradually decreases. Why their energy level gradually decreases here means when the electrons in its excited state, okay, so that will be trapped, the energy which has been possessed by these electrons, okay, that will be trapped, and the trapped energy will be converted into light or heat form, and once the energy has been lost by that electron will come to ground state, and the electrons in its ground state, it moves towards the circuit and reaches the current collectors. So here the hole and electron which were already present, as the migration of holes takes place from PN junction to N-type, this electron holes pair will be created, okay, and hence this process will be continuous as there is a continuous usage of this solar radiations. Okay, so this is the mechanism which takes place in PV cells. Okay, so once again I repeat, when solar radiation or electromagnetic radiation falls on PN junction, the electrons holes pair has been created in PN junction. And I have already explained how silicon produces an electron and a hole when it is doped with boron and phosphorus. Okay, at initial itself I have explained you. Hopefully if it is very clear, then this concept can be easily understood. So when electron hole pair has been created here, what happens? The energy which is absorbed by these electrons will make these electrons to come from ground state to excited state, and electron starts migrating towards p-type semiconductor, and holes will migrate towards the N-type semiconductor, and electrons will move through the outer circuit, and during the movement what happens? The energy of these electrons will be trapped and it will be converted into light or heat form, and once the energy has been lost by the electrons comes down from excited state to ground state and reaches the current collectors where the holes and electrons will combine together. Okay, so this is a continuous and a cyclic process which takes place in PV cells. So unless until the solar radiation falls on PN junction, the PN junction keeps on producing electron and hole pair, and it keeps on generating electricity. So this is about the working of PV cells. Next, coming to its advantages. What are the advantages of these PV cells? The very important one is eco-friendly. PV cells are highly eco-friendly because there is no release of any byproducts, harmful byproducts. Only the usage is solar radiation. And easy for operations. And it has the ability to produce large amount of electricity when the solar cells, that is the PV cells, are connected in series for the production of a large arrays or modules or panels, and the energy produced by these panels will be very much high, so its usage will be more. And next is installation, easy to install, okay, and easy to maintain. So maintenance is very much less when compared to batteries. That is one of its advantage. Okay, the very first advantage of PV cells, advantages of PV cells, it is eco-friendly. It is eco-friendly. PV cells are eco-friendly because it doesn't harm environment, and whatever the materials we are using, mainly the solar radiation, okay, it's a non-renewable source of energy where we can obtain this energy to maximum extent. Okay, so second one, it is highly efficient. Efficiency is more, okay, and installation is easy. It is easy and low maintenance. Low maintenance. These are some of the advantages of PV cells. Coming to its limitations. What are its limitations? So there will be no much disadvantages here, but there will be some limitations. See, this PV cells, it doesn't work during night times because the major driving force is solar radiation. So during night time there will be no supply of solar radiations, and hence the PV cells cannot produce electricity. So it will be inactive in night times, and when the atmosphere is highly consists of more clouds, okay, so then its efficiency gradually decreases. Efficiency is gradually decreases because when solar radiations, when the percentage of solar radiation falls on PV cells gradually decreases, then efficiency or the production of electricity by these PV cells also decreases. So that is one of its limitations. Next, the third limitation is space. Large space is required for installation of these PV cells, because if you want to produce electricity to maximum extent, then we required a huge space for the installation. Okay, and a small panels which has the ability to produce a very small amount of energy just to run one simple lights, okay, then it's of no installation cost is very less. But when the question arises for the production of large amount of electricity, to supply the electricity for throughout the organizations or MNC companies, or for the whole complete house to run all the electric appliances, then installation itself is of very high cost, okay, and it requires more space. So installation cost is very high to produce large amount of electricity, because the cost of solar panels itself is more, okay, and it's not economical, okay. But once the PV cells has been installed, then the maintenance is very less, and we can produce electricity for many number of years without any problem. So these are some of the advantages and limitations of PV cells. Hopefully I am clear about these topics. About the green fuel. So we are very familiar about the word called as green fuel. Nowadays it's more in discussions. Why we are giving more importance towards the green fuel is to overcome this carbon content which is released by industries or automobiles, which is highly polluting the environment. So any particular fuel, when it is burned completely in the presence of oxidant, we know that the chemical fuels, our major composition is carbon. So when this carbon is burned, definitely it releases carbon monoxides or carbon dioxides directly into atmosphere, which is highly polluting and which is also leading to pollution, higher rate of pollution in the environment, which further leading to greenhouse effect, that is global warming. So to reduce this carbon content due to the pollution that has been created by automobiles or vehicles or industries, now we are giving more importance for green fuels. So this green fuel, the name itself indicating, which is eco-friendly, environmental friendly, and which doesn't releases harmful or toxic gases which are very harmful for the environment. So one such green fuel today we need to discuss is about hydrogen. So hydrogen, which is present in plenty in the atmosphere and abundantly available, and it is one of the non-renewable source of energy which can be easily extracted or which can be easily produced just by electrolysis of water. We know that water is available in plenty, and when water is subjected to electrolysis process, it produces hydrogen. But the production of hydrogen is a bit expensive, but still compared to that, when we use this hydrogen as a green fuel, definitely we can overcome the air pollution, because hydrogen, when it completely burns in the presence of oxygen, it doesn't release any harmful gases. It's a non-toxic, and hence we are calling it as a green fuel. So today we shall discuss about the electrolysis of hydrogen, how hydrogen can be synthesized or produced by electrolysis process, that too by considering alkaline electrolysis as an example. So we know that hydrogen is the gaseous molecule which can be stored under a very high pressure, and it's not so easy to store hydrogen under a high pressure in a cylinder. That's also one of the challenging tasks for us nowadays. So first we need to discuss about the synthesis or production, what we call it as production of hydrogen by electrolysis process, So what do you mean by this electrolysis process? Electrolysis is nothing but splitting of molecules into respective ions. We are very familiar about that dissociation. Okay, so here electrolysis process is a process in which a water molecule is split into OH minus and H plus ions by using electricity. So the word electricity, so the driving force in this particular experiment, that is in the production of hydrogen by electrolysis process, is electricity. So by using this electricity, today we need to know how hydrogen can be synthesized from water molecule. Okay, so for this we need to know about a simple diagram which indicates or which represents the presence of anode and cathode and a electrolyte which has been taken during the synthesis of hydrogen by water molecule. So now let us discuss about the construction of this. Okay, in this construction part, first we are considering an anodic material. It will be purely made up of nickel, a porous nickel, and this nickel is coated with asbestos diaphragm. It will be coated with an asbestos diaphragm. So this asbestos diaphragm, we know this specifically what do you mean by asbestos. It's nothing but a substance, like a substance which doesn't change its shape and size even when it is subjected to high temperature, means which can resist the high temperature. So such material has been coated along with the diaphragm to the anodic material, which is purely made up of nickel. And cathode, the presence of cathode on another end, and this cathodic material, it is also coated with diaphragm. So this particular diaphragm, it mainly helps in the movement of a specific ions. It will never allow the other ions to move towards the cathode or anodic part, and it is very specific in action. It is very specific in action, and hence we are using this material as a separator between anode and cathode. This material as a separator between anode and cathode. And in between anode and cathode, there is the presence of electrolyte here. So you can see how the electrolyte is present in between anode and cathodic area. And this anode and cathode both are connected through outer circuit, and it is being connected to a DC source which directly allows the electricity to pass through cathodic area, So now this is cathode and this is anode, and there's the presence of diaphragm, which is purely made up of asbestos material, and there's the presence of electrolyte. So here the electrolyte which we are considering is purely made up of, or consists of sodium hydroxide or potassium hydroxide, because we are discussing the synthesis or the production of hydrogen by alkaline electrolysis process. So we are calling it as alkaline electrolysis process. So see, production of hydrogen can be done in many other ways, but today, since it should be very easy to understand for you people, we are considering alkaline electrolysis process as a best example for the production of hydrogen. So here you can just observe, this is how the electrolysis chamber will be constructed, which consists of anode and cathode, which are purely made up of nickel material, okay, and it has been coated with asbestos material so that it allows only the specific ions to diffuse from anode towards the cathode. And in between there's a presence of an electrolyte, which consists of NaOH or KOH, because we are considering alkaline electrolysis process, and this process takes place in alkaline media. And here the presence of NaOH or KOH, it allows the migration of ions from cathode towards the anode, okay, and the speed of the movement of ions will be more in case of this particular electrolyte, the alkaline electrolyte, okay. So here, once we discuss about the construction part, now we need to know how the water molecule will be fed into the cathodic area. So here we are passing the water molecule from cathodic area, and the final product which is obtained when the water molecule is fed from cathodic area is hydrogen. It will be represented like this. And here at anodic site, the OH minus ions will be consumed, and it leads to release of oxygen. So this is a DC source which is used to pass electricity through the cathodic site. Electricity is always passed through cathode, so it leads to electrolysis of water. And when it has been treated with electricity, what happens? The water will undergo hydrolysis and it leads to formation of OH minus and H plus ions. We know that when water molecule gets dissociated, H2O, it leads to formation of H plus and OH minus. So the released OH minus will migrate towards cathode. It will migrate towards cathode. So here OH minus ions will migrate towards cathodic site. And here, due to the presence of diaphragm, asbestos diaphragm, it allows only OH minus group to diffuse towards the anode, and here OH minus will undergo oxidation with release of oxygen as the product. So this is about a simple construction of alkaline electrolysis process which is used for the production of hydrogen. So now we shall discuss about working here. So in this working part, if you consider, okay, so coming to the working of alkaline electrolysis process, here at cathode, first we need to consider cathodic reaction, because we are passing electricity from the DC source, that is outsource, towards the cathode, okay, where we are feeding water molecule towards the cathode. We should undergo hydrolysis. So when water molecule, when it undergo dissociation, that is electrolysis process takes place, what happens? The presence of water molecule along with electrons, okay, which is being directly sent through DC source, okay, due to the presence of these electrons, it leads to formation of H2O along with electrons. It leads to formation of H2 with OH minus, H2 with OH minus, okay. So here, if you want to balance the equation, so this will become 2 H2O, 2 molecules of water molecule along with 2 electrons. From where these electrons have been obtained means due to the DC source which has been used to supply electricity from the outer source, which has been directly passing electricity towards cathode, and due to the presence of these electrons, the water molecule in the presence of electrons, it leads to reduction, that is what hydrogen gas has been released with OH minus ions. So this reaction takes place at cathode. What happens at anode site? See, the released OH minus group which is present here due to the reduction of water molecule in the presence of electricity will move towards anodic site. As I have told, anode, it is a positive charge, cathode is a negative charge. So due to positive charge, definitely the OH minus group, that is negatively charged group, will definitely attract it towards anodic site. And when it starts migrating towards anode, what happens? This diaphragm, it allows only OH minus ions to diffuse towards anode, whereas it doesn't allow the liberated hydrogen to diffuse towards anode. So only OH minus ions, when it comes in contact with anode, OH minus ions, okay, so this will undergo oxidation and it releases water molecule along with oxygen along with 2 electrons, okay. So if you balance the equation, it will be 2 OH minus. So now if you write the net cell reaction, what happens to the net cell reaction? Okay, so here one water molecule gets cancelled, 2 electrons gets cancelled, one OH minus ions gets cancelled. So the net cell reaction will be water molecule which leads to formation of hydrogen H2 plus half O2, H2 plus half O2. So this is the net cell reaction which you can expect during the hydrolysis of water. So the water, when it undergo hydrolysis, it leads to release of hydrogen gas along with oxygen. So this is the process which takes place during the hydrolysis of water in alkaline electrolysis process. Okay. So once again I am repeating here, in alkaline electrolysis process we are just passing the electricity through the DC source towards cathode, where it brings about the reduction of water molecule from H2O to hydrogen, along with that OH minus ions have been released, and the released OH minus ions will migrate towards the anodic side, and at anodic side what happens, there oxidation takes place, and here OH minus ions, when it undergo oxidation, it leads to formation of water molecule along with liberation of oxygen with electrons. And when you write the net cell reaction, in net cell reaction it consists of water molecule giving rise to hydrogen gas and oxygen. So here the released gases hydrogen and oxygen both can be collected separately in this electrolysis process, okay, by using separate chambers which can collect separately and stored in a cylinders, and it can be used as a fuel, green fuel, for the production of electricity, okay, or to run automobiles. So this is about the construction and working of alkaline electrolytic cell, okay, for the production or synthesis of hydrogen. So coming to its advantages, what are the advantages of these green fuels? As I mentioned in the very first thing itself, hydrogen gas, it is one of the promising fuel, green fuel, which mainly reduces the pollution, air pollution. It mainly reduces the air pollution. Okay, so that is one of its major advantages. Air pollution will gradually decreases if you use this hydrogen as a green fuel. Why? Means hydrogen is a non-toxic. It is a non-toxic, means during combustion it never releases any harmful gases which pollutes the environment. So it's a non-toxic fuel, and efficiency is more compared to other fuels, because 100% combustion takes place, and hydrogen, we know that it releases large amount of energy in the form of heat during the combustion process, and hence its efficiency is very high compared to other petroleum products, that is diesel, kerosene or petrol, which is a renewable source of energies. Okay, and third one, it is very easy to synthesize. It is very easy to synthesize this particular hydrogen. Okay, since the process is very simple, but still the process is expensive. There's a lots of difference between expensive and the process. So procedure in case of alkaline electrolysis is very simple, but the cost effective is more. Okay, because we need to set up the electrolysis chamber by using asbestos as the separators, and along with the energy, that is electricity, which is supplied to the outer source. So hence, cost for the production of hydrolysis, or to bring about the production of hydrogen by electrolysis process, is slightly higher here. Okay, so but it is very easy to synthesize. Okay, so these are some of the advantages of hydrogen as a green fuel, but at the same time there are certain limitations also. So what are the limitations of this hydrogen as a green fuel? The very first limitation is it is very difficult to store hydrogen in room temperature under a high pressure in cylinders. So storage itself is a major problem in case of hydrogen. So it's very difficult to carry hydrogen in cylinders from one place to another place. So hence it is one of its limitations. The second limitation of hydrogen as a green fuel is hydrogen is highly inflammable and it is explosive. it is highly inflammable and it is explosive. Since hydrogen is highly explosive, means which can easily catch fire and which can explode easily when it is stored in a high pressure, okay, so the usage of hydrogen, especially for automobiles, it's of high risk. Okay, so these are some of the limitations as well as the disadvantages of hydrogen as a green fuel. Okay.